Organismal behavior evolves just like any other phenotype, such as size and color. Individuals and populations vary in behavior along a spectrum. Behavior can be heritable, that is, it can be passed from one generation to the next. Behavior can evolve if survival or reproductive success varies between individuals, and this variation in survival or reproduction is non-random. As opposed to the evolution of altruistic behaviors, selfishness can increase an individual's benefit at the cost of others. If selfish behavior contributes to increased survival or reproductive success, it is likely to be inherited and passed down to the next generation. Behavior that decreases the fitness of both the individual performing the behavior, which we will call the actor, as well as the recipient of the behavior, is known as spite. Spiteful behaviors towards less closely related organisms, similarly to altruistic behaviors towards more closely related organisms, hurt the individual performing the action to help overall inclusive fitness or the reproductive success of the group as a whole. For example, bacteria can produce toxins called bacteriocins to stunt the growth of similar or closely related strains in nearby colonies. Even though it's costly for these bacteria to produce bacteriocins, it's worth it for the colony as a whole to have spaces between the colonies, or dead zones, to help them compete less with neighboring colonies. Just as with altruism, Hamilton's rule can apply to spite. If the recipient is less genetically similar to the actor, then the actor that impedes the recipient in some way will have its alleles increase in the population, which increases the fitness of the actor's kin. Another example of when cooperation can go wrong is parent-offspring conflict. When the costs and benefits of altruism change, or when the degrees of relatedness are unequal between family members, conflicts among kin can arise. Parents and offspring often disagree over each other's fitness interests. Birds and mammals often save resources for future offspring at the expense of current offspring. When provisioning offspring, for example in monkeys, there are weaning conflicts or disagreements over when to stop feeding offspring. There is a trade-off between the parent's maximum fitness to provide for more offspring and the fitness of each existing offspring who would want to put off weaning for as long as possible. This can lead to the development of begging, a costly, physiologically demanding behavior that can alert predators. Species that evolve higher levels of extra-pair parentage evolve louder begging. As the siblings in these scenarios are less related on average, there is higher amounts of begging in an attempt to maximize access to food. Another example of sibling conflicts is called siblicide. Siblings can kill each other, sometimes while parents look on. For example, in masked boobies, the older sibling pushes the younger sibling out of the nest. This gives them access to more resources than if they had to share with their sibling. However, in blue-footed boobies, the younger chick is only pushed out in a long-term food shortage. In short-term food shortages, the sibling sometimes even eats less to help nourish the sibling. The parent sometimes interferes and can influence this behavior in blue-footed boobies, while masked boobies do not interfere. Much like how kin selection operates, reciprocity can lead to cooperation. Reciprocity involves an exchange of fitness benefits, separated over time, which results in a net gain for two individuals. While reciprocity can occur among unrelated individuals, it is more likely for reciprocity to occur amongst known individuals. For example, birds are more likely to help their neighbors from a previous year over unknown birds. Reciprocity is mutually beneficial, but leaves the first actor vulnerable to a loss should the recipient choose to not reciprocate. Cheating describes behavior in which an organism receives a benefit at the cost of another organism. In some ways, this should be adaptive if the cheater can get away with it. However, cheaters are often punished. In humans, for example, we have evolved emotions like aggression, gratitude, guilt, and trust to facilitate cooperation. Being evicted from the group, which to our ancestors was basically a death sentence, encouraged reciprocity, even between unrelated strangers. Gobies, which are tiny fish, also punish cheaters. Cleaner gobies, which scrape off the parasites growing on the outside of larger fish, occasionally nibble on the flesh of the fish rather than eating the parasites. Gobies are punished with the threat of eviction, meaning that fish will leave if they are harassed. Gobies can adjust their growth and consumption needs to avoid eviction. So it is the case that while cooperation and altruistic behaviors can evolve, antagonistic and conflict-based behaviors can also aid individuals in survival and reproduction. Some evolve at the group level, like spite, while others involve conflict between individuals. Some even occur between family members, such as in parent-offspring conflict and begging. But whatever the case may be, from altruism to spite, we can now begin to understand the incredible variety of behaviors that natural selection has stumbled upon in order to maximize the reproductive success of a great many species.